Good day everyone. So today our team, Group 11, will be presenting our highway and traffic light result data. Our study primarily focuses on evaluating the impending traffic developments and infrastructure needs surrounding the UMS Smart Hospital Corridor. Without further ado, let's begin by looking at our problem statement. Before we proceed, allow me to introduce the members of Group 11. Our team consists of Samira binti Samichul, Nik Nabila Jona binti Muhammad Jusol, Nur Ardina Shazliana binti Rahim, Amma Aidit bin Yasin, and Alexander Adam bin Azman. Together, we collaborated on the data collection and analysis for this study. Now, let's move directly into our problem statement. Moving on to our problem statement. Currently, the Hospital University Malaysia Sabah is operating at partial capacity. However, it is projected to reach full operation by January 2026. With this transition to full capacity, we anticipate a significant surge in traffic volume along the UMS-HUMS corridor. This influx will be driven by a diverse mix of road users, including hospital staff, patients, university students, and daily visitors. If left unmanaged, this increase in traffic is highly likely to trigger several critical issues, most notably severe traffic congestion, speeding hazards, and acute parking shortage around the facilities. Therefore, this study was explicitly conducted to evaluate current traffic conditions and establish a data-driven foundation to support future traffic planning and mitigation strategies. To address the potential traffic issues we've just discussed, our study is guided by three primary objectives. First, we aim to analyze vehicle speed along the UMS-HUMS access road to identify any potential speeding risk. Second, we will evaluate the current traffic flow at the main intersection to pinpoint congestion bottlenecks. And third, we will assess parking utilization and demand at HUMS to ensure the facility can sufficiently accommodate the incoming influx of visitors and staff. By achieving these three goals, we can form a comprehensive picture of the corridor traffic ecosystem. To meet this objective, we use a three-step engineering methodology. 1. A spot speed study where we measure individual vehicle speeds along the access road. Second is an intersection count to record specific turning movement and peak traffic flow. And last but not least is parking study to closely analyze parking occupancy and turnover rates. Let's take a closer look at how we executed each study. Now, let's look at the breakdown of our first method, which is the spot speed study. We conducted this study along the UMS-HUMS internal access road under free flow traffic condition, where we set up a 100-meter trap line with observers positioned at both ends. Vehicle travel times were recorded using the manual stopwatch method for 1 hour during the morning peak period. In order to determine the vehicle speed in kilometers per hour, we applied the standard formula, which is speed equal to distance over time times 3.6. Finally, we group the collected speed data into 5 km per hour intervals to calculate the mean speed of V50 and V85 percentiles, plotting a cumulative frequency curve to analyze the overall speed distribution.
Moving into our spot speed study results, as shown on the map, we selected a straight 100-meter trap length along Jalan Fakulti Perubatan to capture true free flow conditions. During our 1-hour morning peak session, we recorded the exact elapsed travel times for 50 vehicles. This satisfies our minimum sample size and includes a representative mix of cars, motorcycles, vans, and buses. By converting these travel times, we found a wide gap in driver behavior, with our highest recorded speed reaching 87.8 km per hour and our lowest dropping to 24.2 km per hour. To better understand the behavior of the entire traffic stream, we organize these all data points into the frequency analysis on the next slide. Here is our speed frequency analysis, where we group the data into 10 km per hour intervals to identify driving trends. The distribution shows that traffic on this corridor is highly concentrated, with the vast majority of drivers staying between 30 and 60 km per hour. Our distinct peak sits squarely into the 40 to 50 km per hour range, representing 20 vehicles or 40% of our total sample. Looking at the summary statistics at the bottom, we generated our core traffic parameters. First, the traffic stream operates at an average mean speed of 44.2 km per hour. Our 50 percentile speed V50 indicates that the median operating speed is 46 km per hour. Crucially, our 85th percentile speed V85 was determined to be 61.3 km per hour. In traffic engineering, this is the standard baseline used to establish safe, realistic, and legally enforceable speed limits. Finally, our normal speed range comes out to 54 km per hour. These metrics give us a clear empirical look at current driver behavior, which is essential for any future safety or speed zoning plans along this route.
Moving on to slide 6, we have compiled the traffic volume results for the intersection. This is a T intersection with three main approaches, which is approach A, B, and C. And as you can see, we have compiled the raw data on the left side of the slide. By taking a quick look, you can see that approach C is the busiest leg of the intersection, handling a total of 155 vehicles over 1 hour period. The vast majority of this traffic is either turning left or turning right. In contrast, approach A and B handled a much lower traffic, roughly 40 to 41 vehicles respectively. Finally, if you direct your attention to the bottom of the slides, we have calculated the peak hour factor with the formula of V, which is total all of the vehicles in the intersections, over V15 times 4, while with V15 being the highest 15-minute interval of the intersection. And so we get by calculation we got a PHF factor of 0.69. So in traffic engineering terms, a PHF of 0.69 is relatively low. This indicates a strong peaking characteristics, meaning the traffic was not evenly distributed across the 60 minutes, but rather experienced a significant surge during that initial 15-minute window before incoming traffic becomes low.
So this is our parking located at parking HK Baru. We split the parking into two zones, zone A and zone B. As you can see here, zone A in a blue line and the zone B in the green line. We made the observation at parking HK Baru for 2 hours. There are 3 observers, which is Amaraidi bin Yasin, Alexander Adam bin Azman, and Nur Ardina Shazliana. We make the observation for 15-minute interval, and the total parking at DKP Baru is 69. After that, we selected 10 individual bay turnover, and the users type is all visitors. As we can see in summary statistic, the average duration of stay is 61 minutes, the peak occupancy rate is 82.6%, the time of peak is from 1 p.m. to 1:15 p.m. and the turnover rate is 1.3.
And I